Welcome to the world of science and technology. In today's video, we are going to discuss because it is actually a comparison between Hyperloop and Maglev. Means I am talking about trains. Hyperloop, this is also train, and Maglev, this is also train. Maglev means magnetic levitation trains, and Hyperloop, this is a new concept. Maglev trains. Those are proven reality. Already these are operational in 3 countries, Germany, Japan and China. Okay, Maglev trains. But Hyperloop, this was actually conceptualized by Elon Musk. Okay, and experiments are going on. There is a difference between these two technologies. And the highest speed achieved by, not achievable, but achieved by Maglev trains, recorded value is 603 km per hour. So roughly you can say Maglev trains move at a speed of 600 km per hour. So this is proven reality. But aim for Hyperloop trains are somewhat more, actually twice the value. Scientists are trying to achieve a speed of 1200 km per hour, even more than that. If the speed limit crosses 1235 km per hour, 1235 km per hour, then in that case, that is equivalent to actually, means if you convert that value, kilometer per hour in terms of meter per second, then it becomes 343 meter per second, which is the velocity of sound at normal temperature and pressure. In air or through air, okay, we have to say through air. That is the normal speed of, means sound propagates with this speed through air, 343 meter per second. And you know that when the velocity of any object crosses this limit, limit means I am talking about the velocity of sound. In that case, that is called supersonic. Means in that case, that object is moving with a supersonic speed. So if the speeds of the Hyperloop trains cross this limit, 1235 km per hour, or in terms of meter per second, 343 meter per second, in that case that will be called as supersonic speed or supersonic trains. Anyway, so this was about the speed. But this is just in conceptual level, Hyperloop trains. But Maglev trains, those are the proven reality. So this was the difference between the speeds, right? Next is technology. In case of Maglev trains, those trains remain open to atmosphere. Okay, special tracks are there, but those trains, Maglev trains, remain open to atmosphere during their operation. Means when they are moving from one place to another. Tracks are special. Okay, and in both the cases, but in case of Hyperloop trains, the concept is different. Here, Hyperloop trains won't remain open to atmosphere. They will be actually gliding through near vacuum sealed tubes, near vacuum, okay, not exactly vacuum, but near vacuum means pressure will be very low. That means those trains are not open to atmosphere, Hyperloop trains. So this is the difference between the technology. Why they are making this concept, or why they are doing like this? Near vacuum tubes. What is the necessity? Necessity is that to reduce drag force. Drag force means air resistance. That way, fuel consumption can be lowered down. Okay. There will be savings in fuel consumption if drag force is minimized. But in case of Maglev trains, design is aerodynamic. Means there is an attempt to reduce the drag force. But if you make sealed vacuum tubes or near vacuum tubes, in that case, drag force will be reduced drastically. Drag force will be reduced drastically in case of near vacuum tubes. Okay, and that's why airplane move at high altitude, just to reduce drag force. Okay, because to overcome this drag force, the vehicles, means airplanes or trains, need to consume more fuel. So to reduce the fuel consumption, drag force will be minimized. In case of maglev trains, it is minimized, but in the presence of atmospheric air. That's why aerodynamic design is required, and they do the same thing. You can see easily. From Google you can search for the picture of those trains. You can see the designs are special. Okay, those designs are made just to reduce the drag force. And in Hyperloop trains, what is the technology they are going to use? Yes, they are going to use, because those trains are not operational at present. They are using a new concept, that is, they are reducing the air pressure by removing air from those sealed tubes. That's why sealed tubes are required, to remove air from there to reduce the air pressure. That way they are reducing air resistance, that is drag force. And remaining technology remains the same. Propulsion is required. Okay, means in the forward direction the train should move. That is called propulsion, and for propulsion same technology will be used. Still, that is the concept. In case of maglev trains, what is the concept? Magnets are used. Either attraction or repulsion of magnets are used. Magnets are placed both at the track and in the train, and that way propulsion system works. In case of Hyperloop trains also, same technology will be used. Still, that is the concept. Okay, later maybe they may change the technology, but still this is the concept. Propulsion. Okay. So that means if you talk about fuel efficiency, then conceptually or theoretically you can say that for Hyperloop trains the efficiency will be more, because air resistance or the drag force is reduced drastically. Okay, and speed, it is twice the speed of maglev trains. Though for maglev trains it is already proven reality, but for Hyperloop trains this is still conceptualized. This is just conceptualized. Okay, this is in concept. This is on paper. You can say this way. This is on paper. This exists. Hyperloop trains on paper. Okay. Speeds, efficiency, everything. And due to low emission, I am talking about emission of greenhouse gases. So in both the cases, whether it is maglev trains or Hyperloop trains, in both the cases, the emission of greenhouse gases is minimum. Okay, is minimum, and you can easily compare if greenhouse gas is related to fuel consumption, fossil fuel consumption. Okay, if fossil fuel consumption is more, in that case emission of greenhouse gases will be more. So if in case of Hyperloop trains, if fuel consumption becomes really less than maglev trains, then in that case greenhouse gas emissions will be lowered as compared to maglev trains. That means in that case Hyperloop trains will be much more effective, much more beneficial for our environment. Okay, so scientists are trying to achieve this speed by using this new technology, and I have already mentioned in the very beginning of this video that this technology was conceptualized by Elon Musk. Okay, he is a famous person, known to everybody, I think. If you are a student of science and technology, then you must know that person. SpaceX, the company runs by him. Anyway, so this was all about today's topic, okay? And if you talk about wear and tear or friction, then in both the cases frictions are absent. In case of maglev trains, there is no contact in between tracks and the wheels of the train. No contact when it is operational, means when it is moving, when the trains are in motion. In that case, there is no contact, so friction is absent. So that way wear and tear can be minimized. And in case of Hyperloop trains also the same thing. Okay. So few percent means there is some common technology being used in both the trains. Common technology. Only difference is that maglev trains during their operation remain open to atmosphere, but in case of Hyperloop trains, they remain inside a sealed near vacuum tube. That is the only difference. And due to that difference, many differences may arise. Okay. That is the difference in technology. Anyway, so this was all about today's topic, Hyperloop versus maglev. Let's see what future takes in which direction. Future is not known to us because still Hyperloop trains are not operational. And in both the cases, the infrastructure cost is very high. Okay. And anyway, so future will tell us what the technology actually we are going to use. Okay. Anyway, so this was all about today's video, and this is the end of this video. Thank you for watching this video.